Hi there, everybody. I'm making this video to help you through the Miller Indices section of assignment 4. So the first thing we're going to do here is we're going to load our crystal. In your case, you're going to load diamond. In my case, I've loaded halite, or table salt. So the first thing we're going to do after the structure is loaded is open the inspector menu. If yours isn't open already, you just click this tab up in the top right and it opens up. Next, we're going to navigate to the Model Inspector tab, which is this cube here. You're going to make sure that your unit cell is ticked on and that the multiple unit cells box is ticked here. So we want to make sure we have multiple unit cells ticked. Make sure your axes are on. If they're not, just click the tick box. And then make sure that the labels are set to A, B, and C, not X, Y, Z. Okay? Next thing we're going to do is we're going to make a 3x3 matrix of unit cells. And the way we do that is by clicking range and then clicking add cells twice. So 1 and 2. Now you can see by my red boxes, it's a 3x3 grid of unit cells. Cool. Next thing we're going to do is draw a lattice plane. We do that by navigating to the Volume Inspector tab, which is just one over to the left from where we were. And then in this lattice plane section, we're going to click the gear and then click Add New Plane. And so if we rotate slightly, you can see that there's a geometric plane cutting through the crystal now. Okay? Next thing we want to do is instead of 1, 1, 1 here under the indices column, we want to make this 0, 0, 1. So you probably just saw the plane changed direction a little bit. So now it's running this way across the crystal. And if this is unfamiliar, as it says in the instructions, check out this section of Chapter 11 for a bit more explanation of what we're doing here. That's Chapter 11 in your textbook. And then next thing we're going to do is we're going to move the lattice plane to one of the faces of our crystal. And what that means is we're going to drop down the Move drop-down menu here. You can see that this slider is basically in the center, and the plane is cutting through basically the center of our crystal. That's not a coincidence. What happens if we move it left is it moves towards what in this orientation is the left face. And then if we move the slider to the right, it goes to the right face in this orientation. Right? So it doesn't matter which way you go, just as long as it's on one of the faces. All right. Next thing we're going to do is we're going to change the position of our axial vectors. So if we go back to the Model Inspector tab, just one over, where we were before, we are going to change two things about the axial vectors. We're going to change the position, where this says bottom left, and this little drop down. We're going to leave them there, but we're going to drag this inset slider, and that inset slider shifts them to the center. So now my axial vectors are in here. They're a little difficult to see, so also make sure you change the length of the vectors to maximum. All right, so now you can see them within the crystal structure there. So that's cool. All right, and if this is difficult for you to see at all, like if you don't like the black background on yours or whatever color background yours is, you can go to this Rendering Inspector tab and you can change it to whatever your heart desires. But make sure it's clear. I would stay with one of the neutral colors. It just helps it not be a headache to look at for us. So I'll leave it as gray. Why not? All right, now we are to our first task. We want to copy the graphics to document the structure viewed down the A axis. Okay, we know how to do that. We go to Orient, and we click A, and then we copy graphics. Just Control C, replace the image. Perfect. So notice this next question. When looking down the A-axis, do you see the surface of the lattice plane that you inserted? No, you can only see the if you can only see the edge of the plane, then it is parallel to the axis that you're looking down. If you can see the surface, it is not parallel, and therefore the surface would be intersected by the axis, right? So does the A-axis intersect the plane? Let's think about that a little bit. What that note just said is if we can see the plane in this orientation, if we can see that red sheet that we put into our crystal, then the A-axis would intersect it. I don't see any red sheets. I see my red unit cells, but I don't see the red sheet. And if I use the hand tool and click and drag, I can see that's because the lattice plane is up on top. The a-axis, we can see, because we dragged it into the circle, runs this way, whereas the lattice plane is up on top. So no matter what we do, the a-axis cannot intersect the lattice plane, right? So I'm going to just reset my orientation, looking down the A. I don't see the lattice plane. So does the a-axis intersect the lattice plane? No, it does not. All right, next we're going to change the view so that we're looking down the B crystallographic axis. Same thing, orient, B. Okay, now we're looking down the B axis. We're going to export the graphics again, or copy the graphics, I should say. And replace the image. Sorry, I'm doing that off screen. I've just replaced it. This is looking down the B axis. And now we have to ask ourselves again, does the B axis intersect the lattice plane? Well, I can't see the lattice plane in this picture. I see my red unit cells. I do not see the red lattice plane that would be covering the whole thing. So no, it does not. Next, we're going to change the view so that we're looking down the C crystallographic axis. All right, orient, C. Now we're seeing something. First things first, though, we want to copy our graphics again, replace the image. There we go. Does the C axis intersect the lattice plane? Before we answer, let's think about it a little bit again. So if we rotate our crystal, see now the C axis is pointing straight down, and the lattice plane is on the bottom. So if you can imagine C as like, you know, an arrow from a bow and arrow, if you shot your bow and arrow down, following the C axis, boom, it would intersect the lattice plane, right? If we rotate again, if we orient again and look down the C axis, if we were speeding towards this lattice plane, then we would intersect it at some point, right? So yes. Yes. My text is red there. I've given the wrong answer. I got the red text from the teacher. Okay. Yes, it does. That's the right answer. Okay, so based on the information that we've gathered, what is the Miller index of the plane? Now we already sort of know this because we determined the Miller index of the plane. Way back at the beginning, in the volume inspector, we set the indices as 0, 0, and 1. And if you think about intersection, if you intersect a plane, there's no way to kinda sorta intersect a plane. Right? You're either going to or you're not. It's a binary decision. It's a 1 or it's a 0. And that's how the Miller indices work. If it's a 0, that means that crystallographic axis does not intersect the lattice plane. If it's a 1, that means that crystallographic axis does intersect the lattice plane. So from our information that we did on this document, we know that no, the A does not intersect the plane. No, B does not intersect the plane. Yes, C intersects the plane. So just sort of process of elimination there. These two numbers that we added as 0 are the A and the B axes, and then the C is this last one. Right, so 0, 0, 1. No, no intersection, no, no intersection, and yes, it does intersect. So the Miller indices are 0, 0, 1, and that is our answer here. 0, 0, 1, in parentheses, because that's how you type in Miller indices. And then we want to summarize that. We don't want to just say the answer, we want to explain how we got there. So you would say something about the lack of intersection on A and B, and the fact that C intersects the plane makes this 0, 0, 1. Again, if this is confusing at all, read that section in chapter 11. They'll explain it in better detail, or in greater detail. Okay? Your next step will be just to repeat the process, but with a lattice plane drawn on, or with a new lattice plane drawn. So this time you're on 1, 1, 0. And what that means is we already have a lattice plane. You can just change this to 1, 1, 0. And now we have a new lattice plane drawn, and you will repeat the process. You'll change your orientation down A, B, and C, answer the question, does the axis intersect the plane, yes or no, and then determine the Miller indices based on that. Okay? All right, I hope this was helpful. I'll see you in the next one.